definition of an APY, and you can just read this. I just copied this straight from your book. But it says a common basis for comparing investments is the annual percentage yield, and that is the percentage that compounded annually would yield the same return as the given interest rate with the given compounding period. So what does that mean? If you were comparing rates and you were trying to figure out where to invest your money, and let's say one bank you could invest, and they would give you like a 5% interest rate compounded monthly, and the other bank would give you a 5.5% interest rate compounded daily, and you're like, hey, which one's going to give me more money? Because they're different interest rates and they're compounded differently, I don't know which one to pick. If you convert it to an APY, you can compare those because those are equal. All right, so that's kind of the point of it. There's not a lot of this on your homework, but there's one question I think that asks you to either convert it or to compare two of them, and I just wanted to give you an example here so you know how to set it up. Once you know how to set it up, it's really not bad to do. It's just at first, kind of I'm really happy with my name choices today on our examples. Ursula invests $2,000 with Crab Key Bank at 5.15% annual interest compounded quarterly. What is the equivalent APY? So instead of looking at what we get when we compound quarterly, we want to say what would be the equivalent interest rate if it was only compounded once per year. Okay, that's what APY does. Every time we're going to set this up the same way. So once I show you this, you'll see it's not too bad. So we want to set what APY equals this APR. For the APR, that's exactly what we did yesterday. So do that part first because I feel like we feel good about that, right? If I'm starting with $2,000, that's my P, 1 plus R over K, and that would be what, 0.0515 as my R, and compounded quarterly would be 4. And we're just looking at that after 1 year. So you could really use whatever number you want for time, but I just always use 1 because it makes things simpler. As long as you make the year the same on each one, since we're only looking at 1 year, I always use 1. With me on that from yesterday. The only part over here is I want to know what's the equivalent one if I only compound it annually, which is how many times a year? Once a year. So can I do the same thing over here, except for I don't know what that rate is. I'm looking for the rate, so we can call that R, or we can call that X. And since K is just 1, you don't even really have to put it over 1, but I'll put it there just so you can see it there. Right? It's just once a year, so it actually makes things way easier to solve than some of the stuff that we did yesterday. But you just have to know to convert to an APY, all you do is plug in, set it equal to 1, we don't know what the rate is, set it equal to what we have, and then we're just going to solve this. Could I cancel out these 2,000s? Every time that's going to work. And do you agree on this side I'm just left with 1 plus R? And on this side, I can work that out. I was missing a calculator yesterday, but someone happened to walk out with it. Thanks. I just like to know where they are. If you need one, I'm fine with it. I like to keep track of them. I'm just going to write this out without to the 4th power yet. I mean, we could write it all out. I wrote that as 1.012875 to the 4th power. And what would I have to do to solve that for R? Subtract 1. And again, you could go ahead and do it to the 4th power. I just tend to wait till the end. What you should get is a rate, which means it should be somewhere comparable to 5.15%. If you got like 20% here, there's a big problem. It should be somewhat close. 875 to the 4th power minus 1. I got 0.0525. Or that would be like a 5.25% APY. Anyone having issues with that number? So what does that mean? That means if Ursula was comparing rates around, this rate would be 5.25% if it was only compounded once. And if she had another bank that was offering her something different, she could convert that, and then whichever one is the bigger percentage APY is the one that you would pick. And usually your APY is higher than the one that they give you the other way. So sometimes banks will advertise their APY over their APR because people look at interest rates and they want to see the bigger number, even though it's really the same thing. It's just compounded differently. I think there's like 1 or 2 questions about that today. Not too bad. Hopefully not that bad. But the other big stuff is this one. I love these formulas. Okay, maybe not love, but they're kind of fun. Of course, just like yesterday, I make you write these out. So I'm going to give you the formula the way the book gives it to you, and then I'm going to change it in terms of what I think makes more sense. They use I in this formula, and I feel like that's a bad choice because when we see I, we see an imaginary number, and that's not what this I stands for. So the book writes out the future value of an annuity. This is like if you're investing money. So maybe you want to write that up here. This is for investing money. Like I have a retirement account, and so every paycheck they take out money, and then every quarter they take that sum of money and they put it in my account, and I get interest applied to it. And so that's kind of what this is, a value of an annuity is what that says. So it says future value equals R, where R is periodic payments of R dollars, times 1 minus parenthesis 1 plus I. Oh my gosh, just kidding. I'm giving you the next answer. Look, this is the wrong paper. And one page. It's very similar though. The other way around. It's 1 plus I to the n power minus 1, right? I switched around because that's the next one. Well, I'm going to give you the way the book does it, and then I'm going to give you the other example, or the other answer. This is the book formula, and so I want to give you that first. If you don't like this one, you can just not write it down. I'm going to give you that one, though, because if you look at these words, they use in and I to tell you what that represents, so I like to give you that. But I is really the interest rate divided by the number of compoundings like we did yesterday, so here's my formula that I like. 1 plus R over K, where R is your interest rate, K is the number of times per year, and N is K times T, just like yesterday, minus 1, all divided by R over K. And that one kind of looks worse. I can see why the book uses this because it looks a lot nicer, but I feel like when I see this formula, I know what all those letters mean more than I, which makes me think of imaginary numbers. Aren't you glad I'm not making you memorize this?
So wait, that's not a one equation. Equals is just...
This is the same equation as this, just different ways. This is what I would say you should use. This is what I'm giving you on the test, is that formula. But if you look in your book, it uses I's and N's, so I like to show you what the book shows you, because it's the same thing. I just equals R over K. N equals K times T. So this is a whole lot of calculator work, and this is where you want to be really careful on typing stuff in your calculator and using the correct decimals, because this is really just typing stuff in your calculator, but it's really easy to get the wrong answer, which is why I would recommend, if you don't have a calculator, to get one, or let me get you one, because you want to make sure you get the right answer. Ready? Oh, I'm a little short. Oh, I'm scared. What do anyone else? Yeah? Ready? So how about this? Find the future value accumulated in an annuity after investing periodic payments of $300 for 12 years at an annual interest rate of 6%, with payments made and interest credited quarterly. That's how most retirement things are. Every quarter, they put money in, and they give you interest. So you have to know what to plug in here, and then you have to be able to plug it in your calculator. So R is the payment that you give each month. So the future value would be 300 times, and I always save that 300 till the end when I'm typing in my calculator. 1 plus R, which is 0.06, divided by K, which would be what in this problem? right? Quarterly is when it's happening. So 4 to the quarterly times the number of years. So I'm going to write both numbers up here. That's going to be 4 times 12. My advice would be multiply that out before you type in your calculator because it just creates more parentheses. So that would be the 48th power. Minus 1, all divided by 0.06 divided by 4. People really do use this formula. Most investment people have a spreadsheet or some program that formula is already programmed into it. But that program has that formula in there. And so it's not really just a made-up formula that we pretend to use. I like to do this whole thing at once. You don't have to. And then I multiply by 300. The other option would be do the top, hit enter, and then divide by the bottom. If you do it all at once, I always put the top all in parentheses, and I put the bottom all in parentheses. So I just want you to kind of type on your calculator to see if we get the same answer, no matter which way you do it. And this is where, again, every time there's people that have issues with calculators, which is why I give you points for showing me the work. Let's see, 0.06 divided by 4. Error.
Mine got an error too. I did see it. Can you not have a decimal on top?
Well, are you using a fraction button?
Yeah.
No, you can't use a fraction button. No, you have to do division sign. Right. Minus 1. I think I used maybe a negative sign instead of a, I don't know. Mine's not working. To the 48th power minus 1. Divided by 0.06 divided by 4. Did you do the whole thing at once already? I'm just gonna, if I do just this whole big ugly mess and not the 300, you get 69.565219929. And then when you multiply times 300, you should get a good amount of money. After 12 years, $20,869.57. And did you get that? Anybody need calculator help? I needed calculator help for a while. Having some issues. I always say the 300 till the end. I don't know if that happens, but like I always give the 300 out.
See, one of these makes you appreciate one of those.
I did one for 2 points.
I did it on this, not hard at all.
Yep.
I was stuck with one.
Yep.
I know, right?
Side.
I was.
Side, and I was.
But then when they came to it was like, oh, I don't have to do this already. No.
So you can see how it's easy to mess something up. You should know you should come out with more money than you started with. So if you got like a weird decimal that wasn't even $1, then something's wrong. There's a question I always give on the test about car payments, like how much should your car payment be, and if the car costs this much, blah blah blah. And people always give me answers like bigger than what the car costs. And it just drives me crazy that you don't at least they see that your answer is unreasonable. So like the car costs $10,000, but you came up with the car like you have a monthly payment of $20,000 a month. That doesn't make sense. Or a monthly payment of 7 cents a month. That doesn't make sense. So if you get a weird number, at least you can say, I probably should go back and see if I can type this in differently because something has gone terribly wrong, right? I know that'd be an awesome car payment. I might just pay it in full to begin with. That's if we're investing money. The next formula that I tried to give you for a minute a while ago, that's called the present value. And this is for like payments. I think you should write that next to it. Because on your homework, I don't think that it always says find the present value. But if it talks about a payment, like a car payment or a mortgage payment or a loan payment, you're going to use this formula. And this is if you're paying so much a month instead of investing so much a month. Very similar formula, which is again why I don't make you memorize it. That's why I need my paper, because I don't memorize it. Now R represents the the number of payments, like the payment each month. So present value equals R times 1 minus parenthesis 1 plus I to the negative n, all divided by I. And again, I'm going to change those I's to K's and R's. So that's the same as saying R times 1 minus 1 plus R over K to the negative KT power. Notice it's a negative exponent over R divided by K. Where R is still my interest rate, K is the number of times per year, T is the number of years, R is the interest rate. I think I said that already. But look at this next problem. It says, find the present value of a loan with an annual interest rate of 6.5% and periodic payments of $1,856.82 for a term of 30 years. When I see 30 years, I think of mortgage, because most people's mortgage is 30-year mortgage. But that's a pretty expensive mortgage. My house payment's definitely not that much, but they must live in a pretty fancy house. With payments made and interest charged monthly, and that's how mortgages work. Every month you make a payment, but also every month they charge you interest. And so the bank makes out really well on interest on a mortgage because you take 30 years to pay that off. Yes.
This is kind of just a curious question. What if you move before you pay off your mortgage?
Well, then when you sell your house, and then the money that you make has to go to the bank. But then if you didn't sell it for as much as your mortgage is still owed, then you still owe the bank that much.
So if you sell your house for more than your mortgage is worth, you get to keep the extra?
Yeah, you get to get extra. That's why people hope to sell their house for more than the mortgage is worth, so then they can have a down payment on the next house.
What did you say? I know I missed this, but I just want to make sure. What is the R in this one?
R is, in this one, R is the equal payments of our dollars. So instead of R, in the last problem, R was how much we were investing each month. In this problem, R is going to be our payment each month. This R is always your interest rate. This K is always the number of times per year, and T is always the number of years, and that is in our notes from yesterday. 6.5% used to be a good interest rate, but anymore it's not. You can get a house mortgage for like 3% now. So 3.25, that's what my mortgage rate is on my interest, or my mortgage. So how about this one? Let's see how much they're going to pay for their house. So what we're going to figure out here is how much they're going to pay for their house altogether, which is going to be a lot more than what you buy the house for, right? You buy a house for $100,000, and when you pay interest every month for 30 years, you end up paying a lot more than what you paid for it, which is how banks, make money. 1 minus 1 plus 0.065 monthly would be divided by 12. Don't forget your negative exponent up here. So this is to the negative 12 times 30. Right, that's going to be a really big number. Or small number, I guess, since it's negative. All divided by 0.065 divided by 12. And again, if you don't like a bunch of parentheses, my advice is do the top of this and hit enter. Divide by the bottom and hit enter. Multiply by the number in front, hit enter, and you should get the same answer that I get. If you're not going to multiply 12 times 30, make sure you put parentheses around your exponent. Otherwise, you're not going to get the right answer. Again, we're talking about the total cost of a house with an almost $2,000 monthly payment, which means we should get a pretty big number, right? If your mortgage payment is $2,000 a month, I don't know if any of you know how much your parents' mortgage payment is, but $2,000 is quite a bit. Did you get an answer, Bryce? Your head looks like it's about to explode.
Overflow error.
Oh, that's not good. Did you, due to the, it shouldn't be an overflow error. To the negative 360 power, did you do that?
Yeah.
That number, when you take, this number should be really small, right? Did you do 1 plus that number? about money, we're gonna just go to money. Yes. There you go. 82 cents, Steph. That changes it. All right. So that's just typing in your calculator. Yes, there's issues sometimes, but we could also make you solve for the payment. And so we might not necessarily have, we have like 5 minutes. Let's see if we can please get through this. What if I asked you for your monthly payment? And if you ever go to buy a car somewhere and you get a loan, they come and tell you, well, your monthly payment is going to be around this much. And they're using formulas like this. It says, what is Kim's monthly payment for a 4-year, $9,000 car loan with an APR of 7.95% from Century Bank? If I'm trying to find the monthly payment in that big giant formula, what am I looking for? Which letter am I looking for? R, right? Like I know how much the total is now. Like the total of the loan is $9,000. So what I'm looking for is R. So just like when we can look for the interest rate or the time in the other formulas, we can ask you to solve for something in this. And so we should be able to plug everything else in. 1 minus 1 plus the interest rate is 0.0795. Monthly payment means 12. And 4-year loan seems like a decent loan, right? So that would be negative 12 times 4 all over 0.0795 divided by 12. And so for me, I just got this all down to one number, and then you just have to divide it over. But again, that's just the tricky part of it sometimes. 1, I'll do the top first. 1 minus 1 plus 0.0795 divided by 12. And I'm just going to raise that to the negative 48 power. You should get like 0.271 divided by, on the top. You did this whole thing on the top? I think so. And then when I divided by that, I always put that in parentheses. I got 41.00131941. And again, I just wrote all those numbers down. So to solve for her monthly payment, you're going to divide 9,000 by that giant number. Not really giant, but. Again, we're talking about monthly payment here for a $9,000 car for 4 years, which means your answer, you should be able to tell if it's somewhat reasonable. That's kind of a high interest rate for what we have now. But $219.51, that's a reasonable car payment. $7,000 a month, not reasonable. 4 cents a month, not reasonable. Give me reasonable answers. Not really. So, maybe we need to look at some calculator practicing, right? I'm really upset we didn't get to Pocahontas, Africa. That's my favorite one. Pocahontas, Africa. When I was a kid, I used to tell my mom that if I ever had a daughter, I was going to name her Pocahontas, Africa. I don't know why, but mostly just because it made my mom mad, I think. Angel.
Can you give me their due for tomorrow so I can
Yes. Can you email me?
okay, so I'm gonna go
formulas are